Double A coming back at you once again, but be tuned to every one of you. So what are we doing today, Aimless? We are going to be doing some chemistry. I know what you're saying. Aimless, come on with the chemistry. I get it, man. Listen, I don't like it either. And I'm on the end that it's really giving me a freaking headache. But we are dealing with thermodynamics here. We are dealing with high extreme temperatures, which in anything in high extreme temperatures has a chemical reaction. The matter changes, which is chemistry, which is the study of the change of matter. So we have to deal with chemistry. But I found some neat stuff out. Let's go into these experimentations. First test. This little piece here. This is full strength, not diluted down. This was mixed with Portland cement, and this is mixed with calcium carbonate or lime. It's not a calcium oxide. This is already setting up. It's been probably about 5 minutes. It's already starting to harden. It's taking its time. This is still like a Play-Doh. So I'll let it go for a little while, see what happens. This is strange. The Portland cement has, it's really hard. But the lime, calcium carbonate, it's like silly putty, man. If you leave it there long enough, it'll start flowing out. It's not hardening at all. Now this stuff cures in carbon dioxide, which is a carbon atom and 2 oxygen atoms, CO2. Calcium carbonate, which is limestone that I used, is CaCO2. So a carbon atom, a calcium atom, O3, and 3 oxygen atoms. Portland cement's just a bunch of oxides. That's strange because there's less oxygen atoms in this. There's still carbon. There's no carbons in this. So it's not the carbon atom. It's got to be the oxygen atoms. I don't know. That's just, it's very strange. It seems like if it cured with oxygen, they would say cure it with oxygen. But we're going to go ahead and throw some heat to it real quick. See how it reacts. I expect this to expand and this to just disintegrate. We will see what's going to happen. So let's go with the lime mixture first. Kind of like starlight, but it's not starlight. I'm almost definitely sure it's not starlight. Nobody knows how starlight's made. The government claims they don't even know how it's made.
It's layering off.
Now, that calcium carbonate will heat up and it will release the carbon dioxide. And thinking it'd maybe cure it, but I don't know. It's going to turn it into calcium oxide, essentially, is what it's going to create once it gets hot enough. It still bubbles. Let's try the Portland cement here. I am not getting the same reaction. Oh boy, that's really interesting. Now, why not forge asked me, could you cure it with dry ice? Well, dry ice is frozen carbon dioxide. It's a solid form of carbon dioxide. And I'm sure you could. Dry ice just tends to be a little bit more expensive than other sources of carbon dioxide, which we'll go over that once we cure it in the foundry. Okay, it's turning a brown color, but one of the things that mentioned on the website is that water glass will cure with Portland cement, but the website said that it would do it instantly. I am getting some purple color there for some reason. It's usually a sign of potassium. Is it pushing the potassium out? I don't know. That's strange. Really strange. Yeah, it's getting hot. It's not crumbling like I thought it would. I see little small cracks, but that might be due to something else. So, yeah, let's shut the heat off and see what's going on here. As you can see, it bubbled up and made a shell, and it protected what's on the inside. Now I go to the bottom side, and that's still like Play-Doh. It's acting just like starlight. Starlight was indestructible pretty much. And there's been variations of imitation Starlight made. It only works maybe once or twice, but Starlight basically creates carbon dioxide that pushes it out. And I've seen people hold it in their hand, imitation stuff. But as you can see, that stuff is, yeah, I mean, it formed that shell and it was pretty heat resistant, but that there, I just don't get that. That, on the other hand, that did not bubble up or anything. That is very, very, very interesting. And it seems to be pretty rigid. Pretty refractory, as they say. I don't know. That's just, still pretty daggone hot. I'll say that. But boy, that's kind of neat. Actually, that got really hard. Look at there. I want to hit that again. It's just a really quick experiment on that. That's full strength sodium silicate. Not silica gel. I kept calling it silica gel. It's not. It's sodium silicate. Silica gel is SiO2. Silica gel is the cat litter. But it's sodium silicate. So that was full strength in Portland cement and in lime. Okay? And I know I said that I'm going to say with the lime. But you know what I'm thinking about is maybe I should cure this stuff first with carbon dioxide. And see how it reacts with the lime mixture. So I think that's going to be the next experiment. So we see right now that we are getting somewhere with the Portland cement and the sodium silicate. Now, cool thing is, because this is silicate, because it is SiO2 in a liquid form, it is liquid glass, I don't have to worry about putting silica sand in the mix. That's adding my silicate right there. A high content of silicate, as a matter of fact. And silicate, which is primarily is what quartz is made out of. It's like 3,200 degrees at melting temperature. It's like astronomically crazy. But so we're getting somewhere with this refractory trials. All right. I know we have been all over the place with this, and it's been crazy, crazy, crazy. Down one avenue, back up that avenue, cross the road, zip line to the rainforest across the street, swim through the desert. I know that doesn't make any sense, but I know it's been crazy, man. But y'all, I appreciate y'all bearing with me on this and giving me ideas. Y'all guys are awesome. So I think tomorrow what I'll do is, because this video is going on way too long as it is, just doing that small experiment. But I didn't want to cut any of it out. I wanted y'all to see it in raw footage. So I think tomorrow what we'll do is we will make another batch or another small thing of the lime sodium silicate mixture and cure it with carbon dioxide and see how that reacts, as well as with Portland cement and it dumbed down 1-to-1, and see how that reacts as well with it curing on its own. And maybe I'll make one and let it cure in carbon dioxide. There's so many different experimentations that we need to do and variations that we need to do on this just to see where we can go with it. But we potentially could be getting somewhere. We're closer than we've been before. Yeah. So tomorrow we will go ahead and paint the inside of that foundry and carbon dioxide that bad boy up and go ahead and get it stabilized for the most part. Of course, I've got to dumb that down to a 1-to-1 for it to soak into the dry stuff already. But that is going to be it today, guys. Love you guys. I mean it. Never sell yourself short. Always shoot for the stars. And, yeah, smile. Smile. Take care of each other. Love, peace, and chicken grease, baby. Always remember that.